Right, this is how to use a Anet A8 to print or lay down wire, not using filament. I just want to lay down wire to create a flat winding coil, which is like this. Now, some of you may be aware that this is actually done by Russ from RWG Research. So yeah, it's been done before on a 3D printer. He got good results. I'm trying to do it on Anet A8, so the printer that works on a different mechanism. The bed moves for starters, whereas his one doesn't. So in order to get started, you have to have a shape, and then the issue with the I'm using CURA as my slicer. The issue you'll find with the G-code is it always wants to stop and start. People think saying use the concentric pattern, but that doesn't work because that's again based that you're printing filament where you're able to stop and start. When you're laying down wire, it has to be continuous. So as you can see, the way I started thinking about this was, well, if I was using a milling machine, you can create the toolpath of how you want to mill something out. So if you watch going around, it's actually continuous. It doesn't stop or start. It starts from the inside and works its way out and out and out. So on Fusion, what I did was to give me a bit of a helping hand with regards to the G-code, I had to manipulate where the X, Y, and Z axis was. So where this would usually be your block of material, I made my block of material exactly the same size as what the bed of the Anet A8 is. And then from that, you're literally, to create the path, you're using the morph spiral. And from that, you're able to then, I'm not going to go into too much detail, but from that, you're able to then transport the toolpath from here. Now, once you've got the toolpath and you've converted it into G-code, you can actually see the path it follows to create each, to build it up, as you can see, and then you can see my G-codes running here at the bottom. So that essentially is what I was after. You can't add that in CURA. And as I was saying about the X, Y, and Z axis, it's the same distance from the plate. I found that quite useful because then what I did was I then took the general shape and I sliced it in CURA how you do it normally, which is here. Now, as I was going, I'm just going to go back a point. As you can see, even in shell, and I change it to concentric, it's not continuous. It stops and it starts, it stops and it starts. So for wire, it's not very good. But anyway, I then sliced this up as well. So we've got the same dimensions. And then I looked at the G-code on that. And here it is. And so if I play this, I'm going to speed it up. But essentially, it goes round and is what you expect, and it does all the backfill. And on this case, it was concentric; it was just like the normal lines. Again, that's no good for laying down wire. Let me just make it the normal size. And the point being is my X, Y, and Z from this one is exactly the same as this one, and it's hence why on Fusion you have to make sure you set that correctly. Anyway, for an Anet, or more the I think it's Merlin, it's Merlin, to be able to take the toolpath from your what you've created. There's a lot of code which you can't just sort of like rip out, as I thought, rip out and put in. So this is the G-code for slicing using CURA, and it's got a lot of fundamental information for Merlin to understand. And as you go down, there's some things I've changed, like I've reduced the temperature. But what became apparent to me was, if you look at the code, you have to have this E, and this E is the extruder. Now, if you don't put the, so what originally I did was I literally, all my code here, I literally just copied that and replaced this. Didn't work. You have to put the extruder in. So I took all my code here and actually I winged it in an Excel spreadsheet. There you go. So G1, all the movements from my toolpath, and then for the extruder, like how much to move it, I just took a generic amount and just added it the same amount. So 0.01465 plus 0.1465 plus, and you keep doing it over and over again. And so what I ended up was this. Now armed with, say, G1 to tell it to start, where the position on the X and Y axis is, and how much to extrude. Then I copied it into here. So there's my front bit of my code, which is from CURA. This is the big gap. This is my code from my toolpath. And then at the very end, it goes back to the original code from CURA, the G code from CURA. Now, the only one, not the only one thing, the last point to make this work is if you look here, now where am I? If you look on the lines, it states that it's like 15 millimeters above 0, 1. Oh, there you go. So if you look here, it starts at the 0 position, so X, Y, but Z goes to 15 on the height. And then when it starts moving in, it goes to 0.1. My wire, I think it's AWG38, is 0.1 millimeters. So as it drops down, I had to make sure that the final point of where it drops down is the start point of my toolpath. And then from that, so if I just play that, back, go, play, there you go. So as you can see, it just jumps on and then it goes round and around and round and round. That's what I was trying to do. I know that this works because I've done the video with a biro, just making sure the code works. I've made my little wheel, which now needs to be rethought about, but it does work in principle. So at the moment, I haven't got the wire to show you, but the principle there shows that it is possible using an Anet A8 to lay down cable wire. Oh, and why would you want to do that? I make speakers, so it's useful for that application. Anyway, I hope you enjoyed. I know it's been long-winded. Bye.